All right, excellent. Thank you. So, I want to talk to you a little bit about spatial accuracy and there's been a lot of changes in technology, but I want to introduce first the concept of a digital twin. I think it's becoming a more common terminology. Really is where companies are striving to create a digital model of their physical infrastructure. So for in this example, you see the data collector there down in the ditch. He's got his survey pole, he's collecting that data. And then over on the far right, you see that information loaded back into GIS. And so of a digital twin, if you have an accurate representation in your GIS system of your assets in the field, there's a significant number of advantages for being able to do that. So the more complete and the more accurate it is, the safer it is, the less risk, the more productivity. So, and if we say, well, what are the core parts of a digital twin? It's the what is it, the where is it, and that's what we're going to focus on today, and who collected the data and how that data was collected. Christiane, I think I need control back.
You should have control right now. I gave it up.
Well, I'm not able to move the slides forward, so we have to have one technical advantage of this. So, all right. Terminology, so we can't have a technical discussion without introducing some terminology and some alphabet soup. So what I want to talk about is some of the core concepts. So if people refer to things as GPS, that's really old school. So in looking at old school is GPS is one of the 4 constellations being used. Now there's a total of 4 constellations of satellites that are up there. There's GPS, GLONASS, Galileo, and Beidou. So in that, all those 4 constellations being up there, that means we have access to a lot more satellites to collect information from. RTK is a technique using the receiver to get a 1 to 2 centimeter accuracy real time. Base stations or RTK base stations, it's a known location that broadcasts a correction so that you can combine what you're getting with your GNSS out in the field with a real-time correction, and that gives you real-time accuracy out in the field. If you take and you put a network of those base stations up and they cover your service territory, then you're able to get that real-time correction anywhere supported by the network of base stations. And then if there's not base stations available, the data can be collected and then can be processed back in the office, going out and getting information from those base stations after it's been collected. So here's a graph here, and if we had just 2 constellations, we see over on the left, we have just 2 constellations, and we can see over time, as these satellites are moving around, we get to see a variety of satellites that we'd have. And you can see the number's going to bounce from about 11 to 18 with just those 2 constellations. If we look over on the right and having access to all 4 of the constellations, then we can see at times we can have as many as 30, but the lowest we're going to get is going to be in the high 20s. So in that is that if I have more access to more satellites, that means I can collect data, highly accurate data in more environments. So to explain this a little bit is that we have the satellite that's up in the sky. That satellite signal is being received by the antenna in the field user out in the field. That same signal is being received by the base station. That base station takes a correction, sends it via the cell tower and access to the internet, provides that real-time correction to the field user, so they're getting that highly accurate data out in the field. But these are really the 4 things that are needed to get that real-time correction. So you've got your satellites, you've got your base station, you've got your data collector out in the field who's connected to the internet, and then you have that cell connection. So what does this look like for a field user? So, one of the things is that it's a staggering amount of technology that we have access to. You've got all these constellations, you've got these base stations, but from a field user's perspective, pretty much it just needs to work. And it needs to communicate back to the field user that, hey, the system is working as designed. So if I look up in the upper left of this screenshot, I see a box saying 17. This is the number of satellites that I have a signal from. And in looking at this, I only need 4 to get a position. That's the minimum that I need. So I have 17 satellites. I'm connected to the internet. And if I look, is that this tells me the satellites that I have access to. And each one of these circles would be like a cone looking up to the sky. And so the small circle is what's straight overhead. And what's great to see here is that I've got a really good distribution of satellites, and that they're not all on one side of the screen. They're not low on the horizon. The ones on the outside are going to be the ones with the greatest error because they're coming through the most atmospheric interruptions. So this tells us that we've got a really good distribution, and it tells us which satellites that by color coded of which constellation that I have access to. This gives me an idea of more, more information and details on each one of those satellites that I'm connected to and have a lock with. And probably the most important from a field user's perspective of knowing that the system is working, I have an estimated accuracy here of 0.1 meters. So right now, my estimated accuracy of the data that I'm collecting is 1 centimeter. So I've been doing this for about 20 years. And if you would have told me that with mapping grade non-survey technology, I could have gone out in the field and got a real-time signal of plus or minus 1 centimeter, I would have thought you were crazy. From a field user's perspective, they can look and they say, great, I've got green lights for everything. I'm connected to my base stations and my network. I've got my cell signal and my GPS is working well. So now I just need to collect the data. So as accurate as this is, what's showing on a screen is every second my position is being updated. And what you see here, the scale bar at the bottom is 1/2 foot, but you're seeing it every second that position is updated, it's moving slightly. So it's not the exact position each time. So that creates a problem for being able to load this data back into a GIS system. So we have this problem, and it's called gaps and overlaps. So no matter how accurate my GPS GNSS position is, it's not connected to the other assets. So in a real world scenario, if I'm going to put a tapping T on a gas distribution main, I put that on the pipeline, that tapping T has the same position as where it's connected to the pipe. It's not a few inches off, it's not a different direction. So what happens is that we create either a gap, which means that my GPS position falls, there's a gap between where it is and where I'm supposed to be, or we have an overlap. And these have to be resolved. In the GIS systems of today is that there's a lot of talk around a connected model. And that means that everything needs to be connected so that we can look at the logic and the relationships between all the different assets within the system.
Glenn, Lon asked if you could explain a little bit more about dilution of precision.
PDOP is a positional dilution of precision, and it's an indicator that gives you an idea of how accurate your signal is. The higher the number, the less accurate. And it used to be we'd like to see it under 4 or 5, but now with the real-time correction, we're seeing oftentimes in the 1 to 2. So I'm going to see if I can pause this video. Well, I guess the video is going to go no matter what.
Oh, Glenn, there's one more question that popped
Okay.
up. Let's see, hold on. A moment ago, there was a splash screen showing estimated accuracy of 0.01 M. What AI software was that SNP representing?
So this is out of the CartoPac mobile application.
Actually got a few more questions. So linear versus actual pipe depth. I am seeing this throughout multiple projects.
So we're talking about the depth of a pipe. What's the question, Christiane?
This last question, hold on. So linear versus actual pipe depth. That was the question. I'm seeing this throughout multiple projects. That was from Deborah.
So if I understand so for a position, you can have what is called the X, Y, and Z value, and that's the elevation or the depth. Generally within the GPS technologies is that it's easier to get a more accurate XY location than it is to get the Z value. It can be done, but it requires some additional information to be loaded. That's one of the areas where survey technology really can capturing a very accurate Z value. What we've seen is oftentimes when we're putting solutions out there is that they're capturing the depth of cover, which gives an idea of how deep the pipe is, and that's what we're tracking. So I want to introduce that there's a concept called coincident geometry, is that these gaps and overlaps have to be resolved. And your two choices is I can resolve them out in the field, or I can resolve them back in the office. And if you look at, we have seen where we've deployed a large number of field crews, they've started collecting data and they overload their GIS department with information. And then also sometimes some of those relationships back in the office are hard to understand where they're very intuitive out in the field. So we have enabled a technology in CartoPac called snapping. And what it does is it allows the geometry of two features to be identical. So if I have a riser on the end of a service line, the location of that riser and the endpoint of that service line are the same location. There is no gaps, there's no overlaps. And we're fixing that out in the field. So what we're doing is we're collecting the data, and once we collect what we would call the target feature, then we go ahead and we snap the new feature to that location. So here I'm working on a service line, and I'm going to map my riser, and I'm going to snap that riser to the end of my service line. So the first thing I do is I select the service line, and then I select the vertex on that service line, and I click on snap. That then snaps that riser onto the end of that service line. I'm then able to capture more details about what it is. And I'm also able to keep track of who did it and what procedures did they use. So that's what snapping does, and that's what we've enabled that. We've also got a technology called fast snap, which as you're moving along, you're able to, it knows the last point that you collected, and you say, I'm just going to snap to the last point collected, and it eliminates the step of having to select the feature and the vertex. And from a field user's perspective, we're seeing that we're really boosting their productivity, and we're greatly eliminating or reducing the need to do any back-end processing to load this data back into the connected GIS model. So once this data gets uploaded back into GIS, it's really, as we're doing a great job of collecting the most accurate representation or the most realistic representation of the digital twin. We're eliminating processes on the back end that need to eliminate those gaps. And we also collect what we would call metadata. And people that don't understand what metadata is, it's commonly referred to data about the data, but that defines the pedigree of the data. And I can keep track of, I know how accurate my data was when it was collected and it's stored back in the GIS. So other people who would want to get access to that information, they can look at that metadata and they know that that's a highly accurate position, so they can make decisions confidently based on where that is shown in the GIS. And then we've eliminated those gaps and overlaps. So as an example of this, as you can see, here's a service line that was collected and a meter installed, and it tells me everything that I know about that metadata. I'm showing you just a few examples of the metadata. I think we're collecting, Aaron, what'd you say, 43 different user and GNSS metadata attributes that give us an idea is that we're doing a really good job of collecting the most accurate data possible, and others can look at that data throughout the entire use of that data in this system, and they know how accurate that data was collected. And the other thing showing that gaps and overlaps have been resolved is that if you look down at our scale bar here as a foot, there's that riser on the end of the service line. And even when I zoom in, there are no gaps, there are no overlaps, because those 2 points share the exact same location. So in coming back to the beginning slide of looking at the digital twin, we've gone through the collection process. We've talked about how accurate it is. We've talked about the challenges of having gaps and overlaps, and we see it back within the GIS information. But this is from a CartoPac and the solutions that we deploy. we're doing a really good job of creating a very accurate digital twin of what's installed in the field versus what's being represented back within the GIS and their other enterprise systems. So I think we can open it up for some questions if there's some out there.
There was an additional question in the chat. Aaron actually answered it. It was from Deborah. She had asked, can you overlay ILI data to confirm depth of cover? And I see that Andy answered her. Yes, we can bring tabular and GIS features down to the mobile app, and Aaron as well. He said CartoPac excels at bringing multiple disparate data sources together, such as ILI, OQ, or work order data. Once that data is loaded, we can use to perform various comparisons or data entry updates based on the various data sources.
And Deborah, just to answer, I think your question very, very directly. Overlaying ILI data to determine depth of cover will depend on the type of survey you're overlaying on top of it, like a close interval survey, pipe to soil, things like that. So we can follow up with you on legitimate models that show how you can confirm depth of cover, but absolutely software allows you to overlay. It just depends on all the different types of quality of inspection data you're taking. So we'll follow up with you directly and show you kind of how that looks, confirming DOC. So appreciate the question. Does anybody else have any questions for Glenn or anything we can help to answer for anyone? And you're welcome to unmute now if you'd like. Okay, well, we'll make sure that we have this presentation available for everyone and Glenn's contacts and everyone if you wanted to ask questions or have a little better understanding of high accuracy GPS and high accuracy GNSS location data. We very much appreciate the time today. We really look forward to seeing you in June. And one more question from our friend Rob Floria. Is the FDC app capable of collecting data from a GNSS receiver connected to RTK? So we are currently, the answer is we are working on it. So RTK presents a different challenge, additional layer of software doing the post-processing side as well. So if I think about the Juniper GNSS 3S, that's doing real-time interpolation to get you sub-meter accuracy. But we are working to add our field data collection application to have RTK. Now, CartoPac, and Glenn, you can confirm or go. I mean, I think you already have RTK integration with CartoPac as well, correct?
Correct, yeah. And that's what the majority of our field users are using, is that they're out there getting that spatial accuracy. And I think it's really, it's driven, we often ask the question, what's accurate enough? But it's really is that with the regulations as we understand them, is that you're not going to get the spatial accuracy needed from a regulatory perspective without some sort of correction or post-processing.
I think in general, without needing RTK, you can generally get around sub-meter accuracy without real problems. But when you want to get into sub-centimeter, decimeter, all of the very highly accurate modes, that's where RTK definitely plays a major part. So we are always making sure that our software has those capabilities. And again, happy to answer questions, and we can follow up with anyone who'd like to have a better understanding of what type of accuracy we can provide with our field data collection solution. So with that, if we really definitely appreciate your time, and we'll make sure we have follow-ups, and we'll post the presentation as well. And I'll give it back to you, Christiane. So thank you again.